Hello everyone. Okay, today we are going to learn about resolving vector. Okay, first we want to know the resultant vector. What is resultant vector? Okay, resultant vector is the sum of two or more vector. Okay, let's say a vector R can be considered to be the sum of two vector P and Q. That is R equal to P plus Q. P and Q are known as the component of the vector R. There are an infinite number of vector pairs P and Q that add up to R. Three of these are shown in figure beside. Okay, let's see at figure 1. Okay, this is figure 1. Okay, so this is the vector R. Okay, vector R. Okay, that is the sum for vector P. Okay, vector P and vector Q. We can find the resultant R by using parallelogram method. Okay, figure 2. Okay, for figure 2, okay, this is vector R, which is the vector sum of vector P and Q. And for figure 3, okay, the vector R, okay, as shown in the diagram, which is we can identify the vector R by using parallelogram method. Okay, and then resolving vector. Okay, what is resolving vector? Okay, resolving vector as we want to divide or resolve one vector into two components, which is opposite with resultant vector that we discussed before. Okay, so what is the step for resolving vector? First, we must identify the vector, and then we resolve each vector into two components, which is component X and component Y. Then find the sum of each component and find the magnitude of resultant vector by using Pythagoras theorem. And 5, find direction of resultant vector by using tangent theta. Okay. Okay, if we have one vector, okay, let's say F1, okay, with angle theta. So first of all, okay, we must resolve the vector F1 or force F1 to X component, which is F1X and F1Y for Y component. And then, okay, with angle theta, and then we combine it, okay, to become the trigonometry. Okay, so hypotenuse, okay, we put it equal to F1. Okay, F1, okay, equal to, put it as hypotenuse. Okay, and adjunction, okay, adjunction equal with F1x. Okay, F1x. And opposite is for F1y. Okay, so we can find the sine theta. Sine theta equal to opposite over hypotenuse, okay, which is F1y over F1. So when we want to know Fy, so F1y equal to, okay, F1 sine theta. And cos theta equal to, okay, cos equal to A over H, adjunction over hypotenuse. So adjunction is F1x over hypotenuse F1. So we want to know f1x. So f1x equal to f1 cos theta. And for tangent theta, okay, tangent equal to opposite over adjunction, which is equal to f1y over f1x. So we can simplify, okay, with this equation. f1y equal to f1 sin theta and f1x equal to f1 cos theta. Okay, look at example. The figure shows three forces F1, F2 and F3 acting on a point 0. Calculate the magnitude and direction of the resultant force. Okay, so from this question, we want to calculate the resultant force. Okay, that means one force that represents these three forces. Okay, first of all, we must identify the force, which is for F1. Okay, we must resolve it into two components. Okay, so F1 we resolve it into x component, so we can write is as F1x and y component F1y. And for F2, okay, F2, okay, also we can resolve it into two components, okay, which is F2x and F2y. And also for F3, F3 we resolve it into two components, okay, F3x and F3y. Okay, all this horizontal component of the resultant force, okay, we can write like this. Okay, for Fx equal to F1x plus F2x. Okay, F1x, okay, we write the sign is positive because F1x is at the positive side, and plus F2x also in positive side, and we minus F3x because F3x is at the negative side. Okay, then F1x. F1x, okay, F1x is equal to 40 cos 30. F2x, okay, F2x equal to 50 cos 40. And minus F3x. F3x is 20 cos 50. So we get the answer for x component is 60.08 Newton. Okay. For vertical component of the resultant force, okay, we can calculate the resultant for vertical component. Okay, Fy equal to F1y minus, okay, for F1, okay, we have F1y, okay, positive, okay, because at the upside, okay, minus for F2, okay, F2y is at downward, okay, so we put it negative to F2y, and for F3y, okay, situated at upward, so at positive sign, so we write as positive F3y, and we can solve the problem. Okay, for F1y, Okay, f1y equal to 40 sine 30, okay, minus f2, okay, f2y equal to, okay, 50 sine 40, and for f3y, okay, f3y equal to 20 sine 50. So we get the answer, okay, equal to 3.18 Newton. Okay, so we have the x component, and y component. So we can write this fx and fy component to get the resultant force. Okay, resultant force here. Okay, and to find the magnitude of resultant force, we can use the Pythagoras theorem. Okay, so we get the answer, magnitude for resultant force is 60.16 Newton. And how we know the direction? Okay, direction we can use tangent theta. Okay, tangent theta equal to Fy over Fx. So we can get, okay, value for theta is 3.03 degree. Okay, that's all. Thank you. Don't forget to like, share, comment, and subscribe for this YouTube channel. Thank you.